In this screencast, we're going to talk about analysis of variance, a new kind of hypothesis test. Analysis of variance, or ANOVA, is a test for multiple population means. So we've seen hypothesis testing for just one population mean, or to compare two population means. But ANOVA is a test for multiple population means. So do houses in Fitchburg, Verona, and McFarland all have the same average size? Do math majors, physics majors, nursing majors, and psychology majors all have the same average starting salaries in their first jobs? Do women in excellent, very good, good, fair, and poor health all have the same average weight? So we'll focus on that one. And the basic data that we get from our health data looks something like this. And we see that women can be in various states of health and have various weights. If we make side-by-side box plots that break the groups out using stat key, it kind of looks like the weights differ, although it's a little hard to see. And in any case, this is just a sample. The key to deciding for sure and seeing whether the results that we've noticed are statistically significant is with what's called the F statistic. And the F statistic is a ratio of the variability between the groups to the variability within the groups. So when you look at the data as a whole, when you go back to that screen where we just had the whole block of data, there's variation between the different weights, of course. And that variation comes from two sources. It comes from women being in different groups, being in excellent health or very good health or poor health, but it also comes just due to random variation within the groups. So the calculations are complicated, and you can see them in our textbook. But the ratio of those two variations, called F, is a measurement of how far the observed data is from what you would expect to see if the groups all had the same mean. So a large F leads to a small p-value in rejection of the null hypothesis. Excel does the calculations for us, and on our website you'll see a walkthrough of how to get Excel to do that. But here it tells us that the p-value is 0.000127. So now we're ready to carry out the complete hypothesis test. The null is that the five groups all have the same mean. Mu excellent equals mu very good equals mu good equals mu fair and equals mu poor. And the alternative is that those means are not all equal. Maybe four of them are the same and one of them is different. Anything could be true, but the alternative is just that they're not all five the same. And we saw that Excel gives us a p-value of tiny, and so we will reject the null hypothesis, which tells us that we have evidence that women in excellent, very good, good, fair, and poor health do not all have the same mean weight. If the mean weights for all five groups were the same, there would be only a 0.000127 probability of getting sample means as far apart as the ones we found. By the way, the null and alternative always have the form we see here. So the null is always of the form that all the groups have the same mean. The alternative is that they're not all the same. Consumer warning. To use this test, the individual population should be roughly normal, and the standard deviation of the group should be roughly the same. These are less important for large sample sizes, but for small sample sizes, the further you are from these being true, the less reliable your results will be.